To the lesson where we are going to write the equation of a graph in standard form. We're going to graph quadratic equation in standard form, identify the effect of the a value, and we're also going to write the equation of a quadratic equation in standard form from a picture. So the first one we're going to do is just a refresher of how we actually graph parabola. The first thing we need to know is which way it opens, and the way we check which way it opens is by looking at the leading coefficient a. So it looks like here that a, in this parabola, a is 2. And in this parabola, b, the b value, is 4, and then the c value is going to be 1. Now the way we tell which way it opens is by looking at the a value and seeing whether it's positive or negative. Since it's positive, it opens upward. Now to find the y-intercept, we need to plug 0 in for x. Now the nice thing about the quadratics here is that when I plug 0 in for x, I get 2 times 0, 4 times 0, and then 1. And I add them all together, and it's just 1. And a quick way to remember this is that the y-intercept is always going to be, if it's a quadratic in standard form, my c value. That c value that was there in the equation is going to be our y-intercept. To find the axis of symmetry, I use the equation x equals negative b divided by 2 times a. So I use x equals negative b. What's b? It's 4 divided by 2 times a, which is 2. So I have negative 4 over a positive 4. Negative 4 divided by positive 4 is negative 1. X equals negative 1. Find the vertex now. The vertex of a parabola lies on the axis of symmetry. So what is the x value? Well, it's negative 1. The same value from the axis of symmetry goes in for x. To find the y value, I have to use substitution into the actual equation. So if y equals, and it's 2 times negative 1 squared plus 4 times negative 1 plus 1. I use the exponents first by the order of operations. Negative 1 squared is positive 1. 4 times negative 1 is negative 4, plus the 1 on the outside. Now I do the 2 times the 1. I get 2 minus 4 plus 1. Now I can add and subtract all this together. So I have 2 minus 4 is going to be negative 2 plus 1. And I get negative 1. Negative 1 is going to be my vertex. What's the a value? Well, it is 2. We already know that. Let's go ahead and plot my equation now. So I know where the vertex is. So I'm going to just make my x-axis here. You should be following along in your note packet. Make sure that you are filling this in, because there's really no point to you watching this unless you're actually taking notes. Because it's very unlikely that you'll remember this if you don't at least write the notes down. So I'm going to go with my scales 1. That should be fine for now. We'll find out shortly whether I need to make some extra spaces or not. But I'm going to go every other box is 1 unit. I'll label all my coordinates as clearly as I can so when people look at my graph, they know what I'm doing. So first, let's graph the axis of symmetry. X equals negative 1 is a vertical line, so it goes through the x-coordinate, negative 1. The vertex is negative 1, negative 1. I'm going to graph that on my graph here. And now I need to fill out this table. And the way that we've been graphing in this class for this unit is using the parent function, x, y, and a times y. So you're going to make a third column on your notes, make a times y. The x values I'm using are negative 2, negative 1, 0, 1, and 2. Y is going to be our parent function, x squared. That means you square these x numbers. Negative 2 squared, 4. Negative 1 squared, 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. Now I need to multiply by the a value. The a value is the same a value I have at the beginning of my equation. It's going to be 2 times the x squared. 2 times that x squared. So let's multiply everything in the middle column by 2. And I get 8. 2 times 4 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. Now, because I'm graphing something with an a value, I don't need the middle column, and I'm going to graph all of these other coordinates from where? From the vertex. So I'm going to graph negative 2, 8 from the vertex, negative 2 on the x, 8 on the positive y, 1, 2, 3, 4, 5, 6, 7, 8. So that looks like it's at negative 3, 7, but that's not where we went. I went 2 from the vertex on the left, 8 up. Okay, now I'm going to go negative 1, 2 up. Right here, 0, 0 stays on the vertex, 1 over 2 up. Oh, I went only, just fix that, made a mistake there. 2 over 8 up, like this. Connect the dots, and you'll have your parabola. Okay? Now it's easy to see that compared to the parent function, which it would have been if a is 1, if I graph the normal parent function, and let's use a different color to help myself out. I'm going to use this light blue, and I'm going to let x squared be the light blue. It would have been negative 2, 4, negative 2, 1, 0, 0, 1, 1, 2, and then 4. Okay, which would be right here or so. You can see that my purple parabola is much steeper than my parent function, okay? And that's because the a was 2. You could tell also that instead of going up 1, as like I normally do, I went up 2 for my purple parabola. This is going to be important because now, if I look at an equation, if I look at a picture, excuse me. If I'm looking at a picture and I see this parabola, I don't know what the equation was, okay? I don't know what the equation is. That's the goal. I want at the very end of this to tell what the equation of that parabola actually is. The very first thing that's easiest to see is which way this one opens. It opens down. If I have to explain why, then I'm not really sure how to help you. Okay, the next thing that's really easy to see is I can see where the y-intercept is. The y-intercept is always going to be at 0, comma, something. Okay, and so I look at the y-axis, the parabola touches at negative 3, so 0, negative 3. Another hint is that now we know what our c value should be. It should be negative 3. So at the end of our equation, it should be negative 3. Let's talk about the axis of symmetry. Well, the axis of symmetry should pass through the vertex, which is right over here. Okay, so you can see that it's passing up and down through the vertex at 1. So my axis of symmetry is x equals 1. Find the vertex, I can look at the picture and see visually where it is. It's 1 and then 0 right here. 1 on the x and 0 on the y. That's my vertex, 1, 0. Now to estimate the a value, you have to look at the picture, okay? You have to look at the picture and see compared to the parent function. Typically, I would have negative 2, negative 1, 0, 1, and 2, and I would square that to get 4, 1, 0, 1, and 4. If I just graph from the vertex what that should look like, it would look something like this in orange. Now, obviously, my parabola in teal down at the bottom there, I missed a little bit, let's try it again. My parabola at the bottom here does not go that way. I go, instead of going negative 1, up 1, I go negative 1, down 3. So that makes it pretty easy to see that my a value, I went over 1, down 3, I went 1 over down 3. What would I have to multiply this one by to get negative 3? Well, negative 3. The a value has to be negative 3. Now, again, I said that my goal is to write the equation. So at the very end here, I know that my equation has to be y equals ax squared plus bx plus c. And I know what c was, it's negative 3 because that's the y-intercept. Now to find out what a and b are, well, I know what a is already. Okay, I can put the a in there. The a is 3, negative 3, sorry. The a is negative 3. To get the b value, I'm going to use the x-intercept. The x-intercept here is negative or positive 1. So my equation to get here would have been a times x minus the first y-intercept, x minus the second y-intercept, like that. Okay, so that's what it would have looked like. Now, the only x-intercept I see here is 1. So that means that p equals 1 and q equals 1. P and q are whatever the x-coordinates are of the x-intercepts. So now I'm going to rewrite this as negative 3, because that's what a was, times, and it's going to be x minus 1, x minus 1. I'm subtracting the x-intercepts, and there's only 1. So put that in there, 1 and 1. Now to get my equation, I'm just going to FOIL out. I'm going to multiply the two binomials by using FOIL. Negative 3, and I'm going to use FOIL. First times first, x squared. Outer times outer, negative 1x. Inner times inner, negative 1x again. Negative 1 times negative 1, positive 1. Combine the middle terms, the like terms in the middle. Y equals negative 3 times x squared minus 2x plus 1. I'm going to distribute out the negative 3 to all three terms. I have negative 3x squared plus 6x minus 3. And look, I have the minus 3 and the minus 3 where they're supposed to be. That's going to be my equation right there. Okay, excellent. Here's another example. Which way does this one open? Again, I shouldn't have to tell you. It opens up. What's the x or the y-intercept? I see over here, there's the y-intercept. It's going to be at 0, 1. So for sure, my c value should be that 1. The axis of symmetry looks like it passes through the vertex at -4, right here. So x equals -4. Sorry, x equals -4. Let me fix that quick. The vertex is going to be at -4, and I just look at the graph for this one, -4 and -3. Okay, excellent. Now to find the a value, I compare it to what the parent function looks like, -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. If I graph this, I go 1 over, 1 up, 1 over, 1 up, 2 over, 4 up, 2 left, 4 up. My parent function looks like this. So in orange, my parent function seems to be steeper than my red parabola, which leads me to believe my a value should probably be less than 1. Now if I go over here and check, it looks like instead of going over 1, up 1, I went over 1, up a little bit, but I can't really tell where that is. What if I go over 2, I should have been up 4, but instead of going up 4, I went up 1. So instead of going 2 over up 4, I went 2 over up 1. What would I have to multiply 4 by to get 1? 4 times my a value has to equal 1, so therefore a has to equal 1/4. A value has to be 1/4. Now to get the equation, I'm going to use the x-intercepts of my a value. So I have y equals, it's going to be a times x minus p, x minus q, and I'm going to multiply it out when I'm done to get the standard form version of this. What is the p value, the first x-intercept? Well, looks like the intercept, ooh, this one's kind of hard to use, so maybe I can't use the x-intercept in this one. Well, what do? Well, in this case, I have to try my best, and I'm going to have to use a different method. So I'm going to use the standard form equation again. Y equals ax squared plus bx plus c. And I already know what a and what b and c are. So I know that a is going to be -1/4, positive 1/4, sorry, x squared. I don't know what b is yet. And I know that c is that positive 1. So I'm going to plug in the vertex. So we're going to plug in this vertex, which has a coordinate of -4, -3, and I'm going to plug that in for x and for y, and we're going to be able to solve for b. So let's plug that in. Y is -3 equals 1/4 times, now I'm going to plug in x now, so -4 squared plus b times -4 plus 1. Okay, let's do some simplifying. I have to do the squaring first. -3 equals -4 squared is 16. I have 1/4 times 16. Then minus 4b plus 1. I'm going to multiply again. 1/4 of 16 is 4 minus 4b plus 1. Combine like terms on the side. -3 equals 4 plus 1 is 5 minus 4 times b. I'm going to subtract 5 from both sides. -8 equals -4 times b. Hopefully you follow that. Now I divide by -4. And then I get b is going to be positive 2. So now I have my equation, which was y equals a is 1/4 x squared plus b, which is 2x plus c, which is 1. And there's my equation. That was not a very nice one. Let's try another one. Really quickly, it opens up. Y-intercept is going to be at -3, 0, -3. Axis of symmetry is at -1. The vertex is at -1, -5. The a value, well, it's a good question. Let's compare it to the parent function. If I go 1 over 1 up, instead of going 1 up, I went 2 up, so the a value has to equal 2. Okay, now my equation, I'm going to try to use the x-intercepts again, but again, they don't really work, so I'm going to use a standard form. So I'm going to use y equals, it's going to be, it looks like 2 times x squared plus b times x minus 1. And I have to plug in the vertex, which I'm going to do off camera here to find out what the b value should be. There you have it. I noticed I made a mistake. I used -1 instead of -3. So if you follow my math down, you'll get b is 4, and I can write my equation. See you on Monday.